Welcome all of you. In the previous session of this tutorial, we had learned evolution of the computer languages, means how the development of the computer languages had gone over a period of time. So we had learned the first generation computer language is known as machine language, binary language or low level language, which is understood by the computer only. It was very difficult to use and understand. Also it was machine dependent. The second generation computer language was assembly language, in which mnemonics were used. Mnemonics are special type of keywords. So because of using the mnemonics, writing the program in the assembly language was quite easier than the first generation computer language. But the drawback of this assembly language was remain same. That means it was also machine dependent language. So the program written on the one computer was able to run on the same computer, not on the another type of computer. Translators are also required for converting the assembly language program into machine language. That translator is called assembler. For developing the machine independent languages, third generation languages were introduced. Third generation languages are also known as high level languages. There are many more high level languages. It was very easy to write and understand the program in the third generation high level languages. The languages were machine dependent also. It means that the programs written in the high level languages were able to run on the same as well as another type of computer also. But the drawback of third generation or high level languages was translators like interpreter or compiler is required for converting the high level language program into machine language for the execution. Again, the further development in the computer languages brought for us fourth generation languages. The fourth generation languages are also known as very high level languages, but these are the more closer to the human language than the typical high level language. Therefore, the minimum level of the programming skill is required for the programmer to write the program. Some of the examples of fourth generation languages are SQL, Panther, Oracle reports, etc. And today, the advanced generation computer languages have brought for us fifth generation languages. These languages are known as conditional based programming languages because these languages are designed to solve the user problem using the condition based programming rather than using the algorithm written by the programmer. In these languages, artificial intelligence are used for solving the user's problem. Some of the examples of these languages are Prolog, Mercury, etc. Some problem solving techniques like algorithm and flowchart. Let's start today's topic, problem solving technique. To understand this concept, let us take an example. We know that to do any work, you have to follow number of steps. For example, suppose you have to go to school. To do this work, you have to follow following number of steps. Number 1, you have to get up early in the morning. Number 2, you should be ready for the school. Number 3, you should wait for the school at the bus stop. Number 4, you should come to the school. So in 4 steps, we can complete this work. Can you interchange this step like this? Means can you say that first you should wait for the school at the bus stop and second you have to get up early in the morning? No. All the steps should be in the same order only. Here sequence of the order of the steps are also important. Similarly, to solve any problem by the computer, you should think in how many number of steps the problem can be solved and what will be their sequence of the order before we make the program. This is called building a logic. So before writing a computer program, it is very important to decide the sequence of the steps for solving a particular problem. This means that it is important to building our logic for solving that problem by computer. For that we can take the help of two very useful tools called algorithm and flowcharts. So first, let we see about algorithms. Algorithm is a step-by-step representation of a solution of a problem. Once we write an algorithm for solving a given problem, we can easily design the computer program for the same using the set of instructions of a computer language. You can write the algorithm using simple English language. There are certain rules that you have to keep in mind while writing the algorithms. Remember that your algorithm always begin with the step start, S-T-A-R-T, start, and finish with the step S-T-O-P, stop. Sometimes we can write E-N-D, end also. Second thing you have to remember that you have to give line number for each algorithm step. Third thing is also important. You have to write each step in a separate line. In simple English language you can write the algorithm. And also you have to remember function of each statement should be very clear. Means there should not be the ambiguous words in your algorithm which creates confusion. Let's see how we can write the algorithm for solving a problem to find the sum of two numbers. So first step of our algorithm is always start. So we will write start. Then we will enter two values that will store in some memory locations or variables. So for that, we will write the second step. Enter the two numbers, say n1 or n2. Instead of enter, you can write input two numbers or read two numbers, like this also. Then in third step, we will add these two numbers and store the result in third variable. Let us take an third variable, say sum. So in step number 3, we will write calculate, or you can write perform also. Sum equals to n1 plus n2. In fourth step, we will display the result which is stored in the variable sum. So in step number 4, we will write display or print sum, and our last step should be stop to end the program. So in this way, we can write the algorithm by using the simple English language. So let's take another example. Suppose we want to write the algorithm to find whether the inputted number is positive or negative. So the first step of the algorithm will be start. In second step, the user need to enter some value for the variable n. So for second step, we will write enter any value, say n, or input any number, say n, or read any number, say n. In third step, we will do the comparison and check whether the inputted number n is greater than 0 or not. If it is greater than 0, then after step number 3, we will go in step number 4 and display the message n is positive number. And after step number 4, we will directly go in step number 6 to stop the program. But if n is not greater than 0, it means that n is less than 0, then we will go in step number 5 after the step number 3. And after displaying the message n is negative number in step number 5, we will go in step number 6 to stop the program. Let's take one more example. Suppose we have to write the algorithm to find the largest of two numbers. So our first step will be start. In second step, we will be enter any two numbers and store in the variables x and y. So we will write enter any two numbers, say x and y, or input any two numbers, say x and y, or we can also write read any two numbers, say x and y. In third step, we will compare the values of both the variables x and y. If x is greater than y, then we will go to step number 4 after step number 3 and display the message x is largest number. We will go to step number 6 to stop the program. But in step number 3, if x is not greater than, it means that y is greater than, then we will go to step number 5 and display the message y is largest number, and then in step number 6 we will go to stop the program. Let's see the last topic, flowchart. Flowchart is a pictorial representation of the sequence of the step to solve the particular problem. Because of it is a diagrammatic representation of the algorithm, it helps the programmer to understand the flow of the program. To create a flowchart, some standard symbols are used where each symbol represents a specific type of operation. These symbols are connected with each other by a solid line with the arrow marks called flow lines. First one is the terminal box. A terminal box is represented by an oval sign. It is used to represent the start and end of the flowchart. Second one is the input-output box. Input-output box is represented by a parallelogram. It is used to show the accepted input and output of the program. If in algorithm, read, input, accept, enter, display, print, show, this kind of word have came, we can show that step of the algorithm in pictorial form by input-output box in flowchart. Third one is process box. It is represented by a rectangle. It is used to perform any arithmetic calculation or logical operations. If an algorithm, perform, calculate, such kind of word are came in the step, in any step, that step we can represent in the flowchart by using this process box. Next one is the decision box. It is shown by the diamond symbol. It is used to show the condition based operation for checking or applying any condition in the program. The output of the decision box is in the form of yes or no, or true or false. It has the two paths, one for yes, another for no, or one for true, another for false. Next symbol is connector. The circle shaped symbol is called connector. It is used to connect the chart from one page to another, or to connect two parts of the flowchart. Flow lines are represented by the arrow lines. These are the directional arrows used to put all the steps in the sequence. So let's see how to draw the flowchart. Suppose we want to draw the flowchart to find the sum of two numbers. Our flowchart begins from the start terminal symbol. In next step, we are entering two numbers n1 and n2. Therefore, we use input-output box. In third step, we are finding sum by adding the two numbers. So to represent the calculation, we are using processing box. In fourth step, we are displaying the sum. So to represent the output, we are using the input output box again. And in fifth step, to represent the end of the flowchart, we are using stop terminal symbol. So in this way, we can draw the flowchart. So the flowchart begins from the start terminal symbol. In second step, we are entering a number n. Therefore, we use input output box. In third step, we are checking a condition whether n is greater than 0 or not. So to represent a condition, we are using decision box having the two paths, one for yes and another for no. If n is greater than 0, then we display a message that n is positive number in input output box. But if n is not greater than 0, means n is less than 0, then we display a message that n is negative number in input output box. And in the last step, we use the terminal symbol to stop the flowchart. I hope you understood now how to draw the flowchart. So I am giving here one assignment for you. Try it yourself and draw the flowchart. Thank you very much.